Hello everyone, today I'm going to be talking about Lab 2 for Physics 2 here at Georgia Tech, which has to do with charged modeling of tape. So the goal of this lab is to computationally determine the charge of a piece of tape that it needs to float over another piece of tape. And there's several principles we're going to use here: Coulomb's law, the momentum principle, and superposition. This lab resulted in determining that if it was modeled by a point charge, it would have a charge of negative 5.6 times 10 to the negative ninth coulombs, and if it's determined using superposition, it has a charge of negative 6.79 times 10 to the negative ninth coulombs. So we're going to talk a little bit about Lab 1 and give an overview. Basically, two pieces of tape were created with a negative charge, shown in this top figure. One was pulled off, the other has a negative charge. Two of those U-tapes were created, and they're then changed to tape A and tape B. Tape B was placed on two books, and tape A was held beneath until tape B levitated above tape A. The distance that it took for A to get to B for it to levitate was then written down, and we were able to calculate the charge of tape B. So to do this, we did assume that there was no air resistance. We treated the tape as a point charge, and we assumed the tapes A and B had the same amount of charge. So this is all the data from Lab 1. We have all the given and measured data on the left with all of the calculated data on the right. As you can see, basically, we used Coulomb's law to calculate the electric field force. The gravitational force was used. We know that value. We can use that value. Because of the momentum principle, the particle's not moving when it's levitated, so the electric force has to equal the gravitational force. And then through there, Coulomb's law determined the charge of tape B, which is negative 5.6 times 10 to the negative ninth coulombs. So this is a model of Lab 1 as shown as point charges, and again, that charge of tape B is negative 5.6 times 10 to the negative ninth coulombs. For Lab 2, we're using superposition to model the tape. Now it's not one single point charge, it's multiple point charges, and that'll give us a little bit more of an idea of the true electric field for the tape. So if you see this image down here, this is a depiction of the tape being modeled with multiple charges. So here we're assuming there's no air resistance, but we're also assuming that the tape is treated like there were several point charges and not just one. So the code here, basically, we're given a base code, and from there we were asked to calculate the electric field at each point, which is that formula down in the yellow box below. That formula can calculate the electric field based on a particle's charge and location. So all the electric fields for all of these little particles were determined, and then the sum of all those electric fields gave us the net electric field. So the net electric field was then used to calculate the electric field force, which is the white arrow, and we also calculated the gravitational force, which is the yellow arrow. And like I said earlier, due to the momentum principle, these two forces have to be the same. So what we did is we played around. What charge made these two forces the same? After playing around with the code, trial and error, plugging in different values for Q, or the charge of tape B, we determined that the charge that got the two forces the closest was negative 6.79 times 10 to the negative ninth coulombs. So now let's look at those two charges that we got. Lab 1, negative 5.6 times 10 to the negative 9 coulombs, and Lab 2, negative 6.79 times 10 to the negative ninth coulombs. Now, why is there a difference here? Well, Lab 1 only accounts for electric fields in one direction. It's modeling this piece of tape as one point. The weight is distributed along this tape, but this point charge is only at a singular point. It's not really accounting for that. Lab 2, on the other hand, accounts for the weight being distributed along the tape by modeling by several position or point charges, and this is by superposition, again, doing it with multiple point charges. So because of this, Lab 2 is more accurate because it's accounting for that distribution. It'll also account for the fact that the charges on the very edge of the piece of tape to the far left, they're going to have an X component. It's not just going to be all Y. So in conclusion, the charge that's more accurate is negative 6.79 times 10 to the negative ninth coulombs. If we wanted an even more accurate charge, we basically use superposition, but with more point charges. Get more of those point charges to sum up to make a net field. But yeah, so that is lab 2. Thank you so much.